Doch, nicht. Der Guido ist da.
Ich war also das Ding zusammen.
Der Guido ist der Mensch.
Okay, good afternoon. It's the last session for today. My name is Guido Wirtz. I lost my badge somewhere, but you have to believe me. So we will have 6 interesting talks in around 10 minutes. So it's a SummerSOC version of an approach to some science lab. And I hope our 6 presenters will take the chance to bring their key points and make us all a lot of time to read papers afterwards if we haven't done it so far. So we start with Manuel Fritz from the University of Stuttgart. And I think I will not always tell you about the title because you can do it even better. So it's your turn.
Thank you very much for that lovely introduction, and welcome to my talk about ASAP-DM, which is a framework for an automatic selection of analytic platforms for data mining. As already told, my name is Manuel Fritz, and I'm from the University of Stuttgart, like Professor Mitchams. And this is a joint work together with my student Osama, as well as my colleagues Michael Behringer and Holger Schwarz.
This was over 50% of your time.
That was already 50% of the time, no problem, yeah. That was 75%. Okay. In order to set the context for this talk, please imagine a data analysis process, such as it is described, for example, by the KDE or CRISP-DM process, as we already heard yesterday, for example. And for the purpose of this talk, we focus on the data mining step, right? Because here complex algorithms basically need huge data sets, which result in very long runtimes. Typically, an analyst performs such a data analysis, right? And in order to do so, he uses applications. And in these applications, he basically models such a data analysis process. On the other hand, let's say at a company, for example, there might be the case that there are multiple analytic platforms available, such as Weka, Spark, Mahout, TensorFlow, whatever you name it. And well, basically prior to execution, it is unclear for an analyst which analytic platform he or she should choose in order to come to a result, let's say, very fast, for example. So it may be the case that an analyst starts off by using Weka, but as the data gets bigger and bigger, he may want to switch to Spark at a point in time. However, to do so, we observe 3 pitfalls. The first pitfall is that all of these analytic platforms basically have different APIs, right? So if you have Weka and want to switch, for example, to Spark, it is not that easy. The second pitfall is basically that existing applications, right, where you perform the data analysis process and so on, might not be able to call all analytic platforms. For example, if the application is written in Python and you want to call Mahout, which is written in Java, you have a mismatch in programming languages, right? And it's not so easy to call it from different programming languages. The third and most obvious pitfall is actually what is the best analytic platform for a given problem. Right? So an analyst typically wants to conduct the data analysis as fast as possible. So how can he, which analytic platform should he use? For the rest of this talk, we'll focus on these 3 pitfalls and try to answer the question on how can we support the analyst in finding a well-performing analytic platform for a certain problem. So let us start off with the first pitfall. We have these different APIs with these different analytic platforms, and in order to overcome this issue, we basically introduce a canonical request and response format. So that is, for example, here, as you can see, we have the k-means algorithm, a commonly used data mining algorithm. And here we basically define the input, so the data file that should be clustered, as well as the parameters for the algorithm. Now, each analytic platform can understand this canonical request format, can process the data, and send the result back in a canonical response format. So as for the k-means algorithm, a typical result would be the position of the centroids as well as the sum of the squared errors. Right? In order to realize this canonical request and response format, we assume that all of these analytic platforms are provided as web services. Right? And in order to basically implement them, we introduce the role of the AP provider. The AP provider basically has the task to, as I said, provide these analytic platforms as web services, and also to implement the canonical request and response format. And this now allows to easily change from example, for example, Weka to Spark, right? So we just have to submit basically the task to another platform, to another web service endpoint. However, it is not yet clear where these endpoints actually lie to. What's the address of these endpoints? How can we address them? So this leads us to the second pitfall, basically the possibilities to access specific analytic platforms. In order to solve this issue, we introduced the AP registry module. And here, basically, the AP provider stores the web service endpoint as well of all analytic platforms that are that exist in a certain environment, for example, a company, right? And the AP registry module is especially of importance if we add, for example, new analytic platforms or remove some platforms if they are not supported anymore, for example. Furthermore, we introduced the selection module, and the selection module is basically responsible for selecting a specific analytic platform, transforming the request to a canonical request response format, sending it to the platform, receiving the result back. Right. However, the analyst now still has to select an analytic platform manually, right? So the main question is, can we support the analyst in this manner? Can we somehow help him or guide him in this selection? Which leads us now to the third pitfall, the automatic or the selection of the best analytic platform for a given problem. And in order to support him in this issue, we draw on benchmarks, right? And therefore, we introduce now the benchmark module, which basically performs this. So to understand what the benchmark module does and why we need it, we should have a look at what the analyst typically does and what he pursues. An analyst, when he's performing a data analysis process, he basically submits a data set, and then in the data mining step, he will define a data mining task. Right? And the data mining task is basically the combination of an algorithm as well as its corresponding parameters. And finally, the analyst selects an analytic platform, such as Spark, Weka, or Hoop, where the data mining algorithm is executed. The goal of the analyst is basically to find out to find a well-performing analytic platform for the current problem, right? And best performing platform, those are relative measures that can be measured, for example, by runtime or by CPU or RAM consumption, right? Resource consumption can also be measured for each analytic platform. So if we try to formalize this a little bit, we will see that a data set typically has certain characteristics, right? So such as the number of entities, the number of features, and so on. And we will call these data characteristics capital D. Furthermore, from our canonical request format, we can extract the parameters of a data mining algorithm, right? And we call these parameters capital M. And now the task is to basically select an analytic platform AP. So the main question is, which AP performs best for a certain D and M, right? And this can be expressed as a function, right? So if you have a function f, which basically has the input D and M as input, and tries to predict the analytic platform, right? And here it turns out that current state-of-the-art classifiers are able to model such a function, right? So what we did for our evaluation is to use distinct data sets as well as distinct parameters in order to train and test such a classifier. Okay, our evaluation then showed that significant runtime savings are actually possible, right? So the runtime savings are more than 99%. Yep, thank you very much. Compared to the worst or to the slowest analytic platform in our experimental setting. In order to basically import that into our framework, we introduced the automatic selection component, which models such a function f based on the benchmark results. And this ultimately supports the analyst in selecting a well-performing analytic platform. So to conclude, I want to summarize the main contributions. Firstly, we introduced a canonical request and response format, which allows us to easily change between analytic platforms. Secondly, we introduced the AP registry module, which allows us to basically call these analytic platforms from existing applications. And these calls are based on web services, which are independent of specific programming languages. Thirdly, we showed that an automatic selection of an analytic platform can lead to tremendous runtime savings, and that will support the analyst in selecting an analytic platform. And finally, this enables analysts to perform data analyses faster than before. Well, due to the short amount of time that was given for my talk, I couldn't go into more details. I would be lucky to see you at the poster session tomorrow. Exactly. Thank you very much for your attention.
Exactly perfect in time. So I would advise the next one to settle up, and we have time for 1 or 2 questions. Questions?
That's a good idea. Any questions?
No questions at all?